Hello everyone. So today we are going to solve this question, that is climbing stairs. So the question is that we are given a staircase which takes n steps to reach the top. That means the size of the staircase is n, and we can take either one or two steps every time. So we have to find the total number of distinct ways in which we can climb to the top. So if we take the first example, here the number of steps is 2. So what we can do is we can take one step and then again one step, or we can take directly two steps. So there are total two methods, two ways to reach the top. So the answer will be 2. If the size of the staircase is 3, so we are having three methods or three ways to climb to the top. That is 1 plus 1 plus 1, or 1 plus 2, or 2 plus 1. So what we can do is we can use dp in this question. So we can use this example. For example, if we have some n number of like steps, so the logic is that for any step, if we are considering this step, so we can reach here either by the previous step or by the previous, like the two previous step. So the ways to reach this position will be the total number of ways to reach this position plus the total number of ways to reach this position. So that is any index I will be equal to I minus 1 and I minus 2. That is the sum of I minus 1 and I minus 2. So now we can write the code for this one. So the base case will be if n is equal to 1. So if n is equal to 1, we will return 1. Now if n is greater than 1, that is 2 or more, so what we will do, we will create an array and name it as dp. So the length of this array will be n, and the first value will be 1 and the second value will be 2. Now we will iterate from 2 to n, and the ith value will be the sum of I minus 1 and I minus 2, and finally we will return n minus 1th number. So this will contain the total number of ways to reach n, because the ith index is containing the total number of ways to reach I plus 1 steps. Like if the size of the staircase is n, so n minus 1 index will store the total number of ways to reach that position. So now we can run this code. Okay. Okay, so if we take example of n is equal to 6, so here it will check if n is equal to 1. So n is not equal to 1, so this will continue with the next step. Now I will create a dp array, so this will be of size n, that is size 6, and dp will be initialized with 0. Now dp of 0 is 1, so the dp will be this one, and when dp of 1 is 2, so this will become this. Now we will iterate from I is equal to 2 to I is equal to n minus 1. So I is equal to 2, 2n minus 1, that is 5. So for I is equal to 2, now dp of 2 will be dp of 1 plus dp of 0. So dp of 1 is 2 plus dp of 0 is 1. So this will be 3. So this value will be replaced by 3. Now for I is equal to 3. So dp of 3 will be equal to dp of 2 plus dp of 1. So dp of 2 is 3 and dp of 1 is 2. So this will become 5. So this will be updated as 5. Now for I is equal to 4, dp of 4 will be equal to dp of 3 plus dp of 2. Now dp of 3, this will be 5 plus 3, that is 8. So dp of 4 will be updated as 8. Now for I is equal to 5, dp of 5 will be equal to dp of 4 plus dp of 3. So dp of 4 is 8 and dp of 3 is 5. So this will become 13. So this finally it will be 13. So we will return dp of n minus 1. Now here n is 6, so we will return dp of 5. So dp of 5 is equal to 13. So we will return 13. So we can check this if our input is 6, that is your n. So the expected is also 13. So this is how we can solve this question. And for the time and space complexity, the time will be O of n and the space will also be O of n. Now there is another method that we can use to solve this question. So that is, we can observe that this is a Fibonacci series, that is 1, 2, 3, 5, 8, 13. So basically we have to return nth Fibonacci number. So instead of using this array, we can initialize it with first is equal to 1 and second is equal to 2, and we can use a for loop. So this will start from 0 and I less than equal to n and I plus plus. So we can store the current value as third. So this will be the sum of first and second. Now we will update the values of first and second. So second will become third and first will become second. So here we will change first before second, because second will be updated here and then we can't assign first, so we will assign first before second. And so this will be integer and we will start from I is equal to 3, because for 1 and 2 we have already the answer. And finally we will return second, so which will contain the total number of ways to reach the top of the stair. Okay, so in this case the time complexity will still be O(n), but the space complexity will be O(1), because we are storing just variables and not any array. So this is a benefit if compared to the dynamic problem method. So we can use this method as this is more optimized than the previous one. So that's all for this question. Thank you for watching the video. Do like, comment, share and subscribe the channel if you like the video, and the code for this will be given on my GitHub page. You can check out the link in the description. Thank you.